Hey, this is Mr. Medic. I'm going to give you some notes on section 5.5b, which is about half-angle formulas, which I've drawn them all right here. They're also on your trigonometric identities page. They're also in the book in section 5.5. It's the third set of rules, and you have to do page 418, number 27, which is not a half-angle formula. That one is the power-reducing formula. One more example that you have to deal with. And then you have to do 32 through 58 even, which all of those are half-angle formulas. So the first one, I'm going to get you started right away. 32 begins with this triangle right here. And you might remember the numbers 5 and 12. That's a Pythagorean triple. If you don't remember, you can use the Pythagorean theorem, but what we're going to find out is that that side is 13. So we're going to look at question 31. Question 31 says, you're trying to find the cosine of theta over 2. Now that's going to be the second formula here. So the plus or minus on these has to do with what quadrant you're in. Since we're talking about a positive triangle here, this is going to be quadrant 1, so we're never going to have to worry about the signs. But later on, they're going to ask us a little more tricky questions about angles that may or may not be in a positive quadrant, so you have to know how to do that. But the formula we're going to use is we're going to use the plus part of that because we're in quadrant 1, and we're going to say 1 plus the cosine of our angle theta right here. Okay, so our angle theta has a cosine of 12/13. So we're going to put the square root of 1 plus 12/13 over 2. Now this is going to take some algebraic manipulation. So let's rewrite this as 13/13. Which will let us simplify this as 13 plus 12 over 13 all over 2. 13 plus 12 is 25, so we get the square root of 25 over 13 all over 2. Now if we use the copy dot flip method for this denominator, we're going to end up with the square root of 25. No, I don't want to write it that way. Let's write it this way. The square root of 25 over 13 times 1 over 2. And so that ends up getting us with the square root of 25 over 26, which the square root of 25 is 5 over root 26. So the last step is it's going to be 5 root 26 over 26, and that's our answer. And I verified at the back of the book that is in fact the answer. And we wanted the positive version of that because we were definitely in quadrant 1. Okay, then let's take a look at number 37. 37, I kind of trick you on this. I'm only assigning the odd problems. But if you take a look at number 38, you'll see what I'm talking about. You're going to get sucked into doing some of the odd problems anyway, even though I've assigned you the odd one. Even though I've assigned you the even ones, you're going to end up doing some of the odds. In this case, it says the sine, 2 times the sine of theta over 2 times the cosine of theta over 2. Well, I just calculated what the cosine of theta over 2 is. It's root 26 over 26. So you're going to get 2 times whatever the sine of theta over 2 is, times 5 root 26 over 26. Now, where are you going to get the sine from? Well, if you look in the book, that's actually the answer to number 32. So once you put that answer to 32 in here, this thing simplifies itself rather nicely, and you'll end up with a very easy to recognize answer. Let's just put it that way. Okay, let's see how we can use one of these formulas to actually do find an actual sine or a cosine or a tangent. And I'm going to do all three. We're starting with number 39. So we're looking for the sine of 15 degrees, we're looking for the cosine of 15 degrees, and we're looking for the tangent of 15 degrees. Now 15 degrees is in quadrant 1, so although this says plus or minus, we know that every one of these answers is going to be a positive. So that is equal to the sine of 30 degrees over 2. And our formula is going to take advantage of that by saying 1 minus the cosine of 30 degrees over 2 to get the sine. So let's see, I'm going to draw a 30-degree angle. It's a 30, 60, 90. The cosine is going to have that long side, which is root 3 over 2. So I'm going to end up with 1 minus root 3 over 2 over 2. And as you can see, what this is going to be, this entire assignment is really going to be, can you learn how to manipulate complex fractions? So again, I'm going to want this to be a common denominator, so I'm going to treat that 1 as though it is root 2 over, is 2 over 2. So we're going to end up with 2 minus root 3 over 2 over 2. Now make sure that radical goes all the way down, includes the denominator there. So we're going to end up with the square root. If you haven't figured it out yet, when we did this little trick here, we ended up multiplying this denominator and that denominator to get the new denominator, which was 26. So in this case, these two denominators get multiplied. You're going to have 2 minus root 3 over 4. Now, out of that, I can take the square root of 4, which that's going to get me 2. And so my final answer is going to be 2 minus root 3 over 2. That, believe it or not, is the answer. That ugly-looking embedded radical is actually the answer to the sine. Now the cosine, if you'll notice, I'm going to show you something. You might be able to do a little shortcut here, and I'm able to do this shortcut, and I think you can too. It's going to look like this. Now if you'll notice, it's pretty much the same as this formula, except for the fact that that says minus there, and here it says plus. At the end, that minus ended up being there, and then there, and then there, and then there, and then finally showing up there. So now what if it was a plus? What if it was a plus? What if it was a plus? Guess what? We're going to end up, you can do the manipulation if you want to see that I'm right. But you're going to end up with the square root of 2 plus the square root of 3 over 2. That's our cosine. And no, I'm not going to ding you if you've already calculated the sine for figuring out that the cosine must be that. Okay? Now, I know what you're thinking. For the tangent, can't I just put the cosine over the sine? That's actually not a good idea, because then we can have this double radical. This double embedded radical would be in the denominator, and it's not a lot of fun to rationalize. It's much easier to use the formula. And now, which formula should I use? Well, let's go back to this triangle for a minute, this 30-degree triangle, which I drew right here. And remember that this is the sine of theta, and this is the cosine of theta. Now, how do we decide which formula to use? Well, one formula puts the sine in the bottom, the other one puts the cosine in the bottom. What we really don't want is we don't want a radical in the bottom. Lucky for us, only one of these is a radical. The other one is not. So we want that radical to be in the top of the fraction and the non-radical to be in the bottom. The non-radical is the sine. So that's what, this is the formula we want to use. So the tangent of A, tangent of 15 degrees, we're going to say is the tangent of 30 over 2 is equal to, what was that formula? 1 minus cosine over sine. 1 minus cosine over the sine. And the sine, that's 1 minus the cosine of 30 degrees. degrees over the sine of 30 degrees. So you're going to see that this is actually really quick. The cosine of 30 degrees we said was root 3 over 2. So I'm going to put 1 minus root 3 over 2 on the top, and on the bottom I got the sine of 30 degrees, which is 1 over 2. Oh, if this were only a fraction right here, I think we can do that. I think we can do that. Can't we change this to 2 over 2? So we're going to end up with 2 over 2 minus root 3 over 2 over 1/2, which is 2 minus root 3 over 2 over 1/2. And as we've discovered before through copy dot flip, these halves cancel, and our answer is 2 minus root 3. That looks like a familiar answer. I think we've seen ones like that in the past. And so there's your number 39, and it goes just like that. Okay. Now 41 is pretty similar to that. I'm not going to do the whole problem, but I am going to point out to you that it's actually much easier than it looks. 41 asks you to find the sine, the cosine, and the tangent of 112 degrees 30 minutes. Well, remember that we're going to really find some number that I can take half of and get that. Well, that is 225 degrees, because that's 112 and a half plus 112 and a half, and that's 225. Now this one is on our table, which means we should be able to find the calculation. By the way, which quadrant is 112 and a half in? If you said quadrant 2, you'd be right. So in quadrant 2, the sine is negative, isn't it? No, it isn't. Quadrant 2, sine is positive. The cosine is negative, and the tangent is negative. Now that's how you'll decide when you start to look at those radicals. If I'm using the sine, I'm going to say plus. If I'm doing the cosine, I'm going to say minus, or the tangent. Okay? So that's how you do that. Let's take a look at an interesting problem a little further on, and that's number 47. And number 47, they say use the half angle formula. No, find the exact values of the sine of u over 2, cosine of u over 2, and the tangent of u over 2 using the half angle formulas. So on 47, it says that the sine of u is 5/13. I think I saw that recently, didn't I? 5/13. This is this triangle again, isn't it? Okay. Well, for kicks and giggles, do you know what the cosine would be then? Well, wouldn't it be 12 over 13? Except in 47, it says that u is between pi over 2 and pi. That's quadrant 2. And according to what we've memorized, although the sine is positive there, the cosine would be negative. So it's not just 12 over 13, it's negative 12 over 13. Okay, now that's helpful. You're going to have to know that, because now we have to figure out about u over 2. Now u over 2 would have the same inequality as this, except remember that u over 2 is going to cut u in half. Well, everything gets cut in half. So for u over 2, what quadrant are we in? Because we cut each one of those in half. Well, it's between pi over 4 and pi over 2. This is pi over 2. This is pi over 4. So we'd be in the first quadrant. So this one's going to be positive by the time we do the calculation. Okay, now that we have the sine and the cosine is the important one because the formulas all depend on the cosine there. So let's do the sine. The sine of u over 2 is going to be the positive end of 1 minus the cosine, which is 1 minus negative 12 over 13 over 2. So to simplify this radical, I'm going to treat that 1 as though it's 13 over 13. Now do keep in mind that this says minus here and that says minus there, so we're really going to be adding. So that's going to end up being square root of 13 plus 12 all over 13 all over 2. And now the trick we learned up here is that when I want to have a compound denominator, like this 13 and this 2, they end up being multiplied together to become the new denominator, which in that case is 26. So let's see what we end up with on this one. Guess what? It's the same denominator, isn't it? It's still going to be 26. In the top I'm going to get 25. So it's the square root of 25 over 26, which is again 5 over square root of 26. Or in other words, 5 root 26 over 26. Yeah, I've seen that problem before, haven't you? Now the cosine of the tangent, you just follow the rules just like it says up here. If you want to see some more, there's another video connected on the web page. You can certainly look at that. It's on YouTube. But I think I'm done with 47. So now let's talk about 51, which is like 52 and 54. In 51, they give you the square root, and this isn't plus or minus, this is the plus version, of 1 minus the cosine of 6x over 2. And they've decided that since you've been exposed to going forward, now let's see if you go backwards. Remember that this is the answer of a half-angle formula. So which one does that look like? Does that look like the sine, the cosine of the tangent? I see a minus right here. I think it might be the sine. That's what it looks like to me. That looks like the sine. So the sine formula says that this is double what the original angle was. Okay, so in the sine formula, if this is A, I cut it in half to find this one. So that's all I have to do. Let's cut that angle in half and we're there. So this is equal to the sine of 6x over 2. Or in other words, the sine of 3x. And we're done. That's how you do 52 and 54, which are easy. 55, on the other hand, is not as easy. It's much more complicated. Okay, so let's take a look at 55. And this one is, there's only a couple like this. So they said find the zeros when you have f of x equal to the sine of x over 2 minus the cosine of x. Now this answer is kind of interesting. But anyway, we can't have two different kinds of angles. We got it here in x over 2 and x. Those are two different angles, so that's not permitted. We have to get rid of those. We have to turn the x over 2 into just an x. So now we're going to use the formula, and in this case, that's going to look like, first of all, we have to set it equal to 0 because it says we're looking for the zeros. And the formula is the plus or minus square root of 1 minus the cosine of x over 2. That's what the formula says. Minus cosine of x. Well, I'd like to square this so I don't have that radical anymore, but I can't do that when there's a buddy next to it over here. So what I'm going to do is I'm going to add cosine of x to both sides, and we're going to end up with cosine x is equal to plus or minus square root 1 minus cosine x over 2. Now if I square both sides, I'm going to end up with cosine squared x is equal to, now the plus or minus doesn't matter because when I square it, I'm going to end up with a positive anyway. I'm going to end up with 1 minus cosine x over 2. Well, I think I'd like to move that all over to one side and make it equal to 0, because I think this is going to factor. But on top of that, I'd like to get rid of that 2. So I'm going to multiply both sides by 2. That multiplying both sides by 2 gets me 2 cosine squared x is equal to 1 minus cosine x. Now we'll subtract them all over onto the same side, so we're going to end up with 2 cosine squared x plus cosine x minus 1. Guess what? This thing factors. Well, that's a 1, so this has to be a 1, that has to be a 1. That's a 2, so one of them has to be a 2, one of them has to be a 1, cosine x, because the sign is different. I can have a plus and a minus. It looks like this one would have to be plus, and this one would have to be minus. And if I set those two equal to 0, this one's going to get me cosine x equals 1/2, which means x is pi over 3, and 5 pi over 3. This one's going to get me cosine x equals -1. And so where would the x value be equal to -1? Well, that would be a pi. But here's the problem. That's actually not a solution of the original problem. If I put pi in here, I run into a problem real quick. Okay, if I put pi in here, I get an interesting answer. Remember that the cosine of pi is -1. So I end up here with plus or minus 1. And then if I have a 1 here, because this is also going to be a -1, I'm going to end up plus 1. So it doesn't really work. It kind of works, but it doesn't really. So this isn't really a solution. And that's how you do the harder problems in that set.